All right, so welcome back to the Civil FE exam review. We are currently in the structural engineering section, and we are wanting to dive a little bit deeper into the design of steel components section. So I have some practice problems for you all here, but I also want to share that to me, this is one of the more challenging sides of our problems when it comes to, I guess, solving and going through on the exam. Now, for some people, it may be easy. Some people's strengths are structural engineering, but mine was not. So as I'm going through these, hopefully it will help you if you're similar to me and struggle with structural engineering. So let's go ahead. Let's take a look at some of these problems. All right. So number one says calculate the design shear strength of a W24 by 62 shaped steel member, where Fy is equal to 50 KSI. All right. So what information are we given? We're given that Fy is equal to 50 KSI, and we are given that it is a W24 by 62. What are we trying to find? We're trying to find the design shear strength. All right, I don't even know where to start. I think the best thing to do is always to search what you're trying to find, right? So design shear. Just do design shear. All right. So design shear strength of a section is the symbol phi sub Vn. All right. Phi sub Vn. All right. Anything else? Okay, the design shear strength phi sub Vn is determined with phi sub V. It's 1, so that's phi sub V. And then V sub N is equal to 0.6 times Fy times AW times CVL. Okay. So gauging from this, right? If I just look at this, I know that I'm looking to get phi sub Vn, right? It's the only, yeah, this is all I have to work with, right? After I did all my searches. Okay, so I'm looking for phi sub Vn, where phi sub V to 1, this is a web of rolled I-shaped members. So phi sub V is 1. V sub N is equal to question mark. And we also know that it is, that's what we're solving for, right? Or we're not really solving for that. We're solving for phi sub V sub N. So if I have phi sub V and I can multiply it by V sub N, I can get my answer. So V sub N is going to be 0.6 Fy AW CVL. Okay. Do I know any of these variables? What is F of Y? Oh, they give it to me, but I still want to know what is that. So it could mean the specified minimum yield stress, but I think that's for that section. So in the beginning of the design of concrete members, or sorry, this is the design of steel. But I think it's pretty uniform for I'm going to go with the specified minimum yield stress. Either way, they give it to us, and this Fy is 50 ksi, which is a stress. So we can say I know F of Y, which is 50 ksi. Remember, stress is always your weight or newtons over a specified area, right? So in this case, it's 50 kips per square inch. That makes sense. 50 ksi. Okay, so Fy is taken care of, right? Fy. What about AW? What is AW? Okay, AW is the area of web. Okay, the overall depth times the web thickness. Okay, so we know we don't have AW, so AW is equal to the depth times the web thickness. Okay, and that's going to be in inches squared, right? All right, what about CVL? Well, CVL is equal to 1. All right. Okay, so we have that. All right, so we're slowly putting the pieces together. How would we get the area of the web? Well, we know that it is a W24 by 62 web. So is there any place where we can look and get that information? Well, there are tables with different webs that give you different things. So W shapes, dimensions, and properties. So in your FE handbook, there's a chart that has different sizes of eye shapes for your members, for your steel members. And you can go through and get the area, just the general area, or the depth, or the web thickness, BF. I don't know what BF stands for, but inertia, moment of inertia of these different shapes. So a lot of different things that you can get. But in this case, we're looking for a W24 by 62. That would be here, right? And then we want to know the depth. Well, we want to know the area of the web, right? This is what we want to know. But I know that from this chart, it doesn't look like they give us that. But they do give us D, which is the depth. And then they give us the web thickness. So they give us D, which is 23.7, right? So I'll just put D is equal to 23.7. Notice this is in inches. That's the depth. And that is here, right? So that to me reminds me of the height, but hey, that's neither here nor there. D is equal to 23.7. Okay. What about T sub W or TW? TW is the web thickness, right? And that web thickness for a 24 by 62 is 0.430. T sub W is equal to 0.430. 0.430. Okay. So now we can get the area of our web, right? So now say area of the web is equal to 23.7 inches times thickness of our web, which is 0. This is inches. 0.430 inches. And an inch times an inch is going to give you inches squared, right? And when we multiply this out, we get 10.191 inches squared. Cool. So now we have area of the web. Have all the variables that we need in order to go ahead and finish solving this question. All right. So phi sub v times vn is equal to 1, right? Where am I getting the 1? That's phi sub v, and then multiplied by v sub n, which is all multiplied by 0.6 times my 50 kips per square inch times my 10.191 inches squared times what else? 1, and then that should be everything. Whoa. All right, so for my ultimate design strength, I end up getting 305.73 kips, right? Once you write everything out nicely, you know that your units cancel, and you're just left with kips. Okay, so my answer is going to be D. A lot of parts to put together, but once you get it, you're good to go. All right. Next one, number 2. It says select the appropriate W shape using the following information. All right. Available moment is 372 kip dash feet, and then the unbraced length is going to be 14.5 feet. So let's go and write down the information that we're given. So we're given the available moment, and we're also given the unbraced length, and we're trying to find, what are we trying to find? The W shape. So we really gotta figure out how to get this. So formulas that we need, how can we get a W shape given the information that we have? So let's look up available moment. So important that you understand your handbook and know which charts are going to be in your handbook. So studying this thing up and down, doing enough practice. That's why I'm sharing these problems with you. All right, so in this chart, you have W shapes where you can select the available, or you have the available moment listed. And then you also have unbraced lengths. Okay. So how do we use this chart, right? Well, we know that the available moment is 372 kip feet. So along this chart, this is in kip feet, right? The available moment. So I know along this line, I should be looking for 372. Okay, so how do I know where these numbers end up, right? Is it 1, 2, is this 361? Well, if I say 361, I say let's zoom in here so you can see. I don't believe that this would be 361. Here's why. So if I do 361, 362, 363, 364, 365, this says 375. So I know that that's not correct. So the difference from 375 to 360 is 1, 2, 3, 4, 5. So I know that each line is going to be each line is going to be my distance, which is 375 minus 360 divided by 5 lines, right? And so each line should equal 3. So when I do that, let's check it to see if that analysis makes sense. So 363, 366, and then 369, 372, 375. So I know that each line is in fact 3. Okay. So now how do we get how do we get to 372? Well, I know that it's if I go down 3, it's this line, right? Okay. So now I know I'm on the right line, but how do I use this chart still, right? So it's hard for you maybe to see, but hopefully you have this pulled up on your computer as well. So the next part is taking and finding your unbraced length. And what you're going to do is you're going to connect the two pieces. So 372, I'm going to ride all the way out until I get to my 4.5, right? Okay, so what's the distance between here and here? Well, I know it's not 1, because 1 would be 4, this would be 14, this would be 15, this would be 16. That's not the case. So I would again do my 16 minus 14 divided by 1, 2, 3, 4. And that means each line 16 minus 4. Whoa. 16 minus 14 divided by 4. Each line is equal to 0.5. Okay. So I know that 14.5, 15, 15.5, 16. Okay. So where's my 14.5 feet? All right, it's here. Okay, so we want to come up and connect right where 372 would be. And we meet right here where my marker is. Now we want to highlight that what we have to figure out what W shape is equal to this, right? So I come over to 372 and 14.5. The dashed line that I get is at 18 by 65. So the W shape is going to be 18 by 65. So my answer is A. All right. So it's very important for you to know how to read this chart. Also note that my FY was 50. So that's pretty typical, but just making sure you know, okay, CB equals 1 for this, and just pulling out your important information, right? This looks like a bunch of scribble, but each line represents a different W shape. So you can really use this to your advantage if you know how to read it. So, all right, so that was A. Let's look at number 3. Right. Number 3 says, based on the plate shown, what is the transverse spacing between line of holes? All right. So what information are we given? Well, we're given a plate with staggered holes. All right. The holes are staggered. They're going one direction, another direction. So going from here to here to here. So it's a bunch of different directions they're going. And they're not all like staggered versus not staggered. What do I mean by that? Well, if you had a beam where all of your reinforcement rebar was in a straight line, then it wouldn't be staggered either that way or coming down like that. It's all in the same straight line, so it's not staggered. Staggered means it's just kind of going zigzag. Okay. All right. So we know that they're staggered, and it's a plate we're looking at. What are we trying to find? We're trying to find the transverse spacing. Between the line of holes. All right. Okay. So what are the formulas that we need? Well, I'm gonna look up transverse, maybe. Okay. Radial and transverse components for planar motion. This is in the dynamic section, so I don't think that's what I need. Still in the dynamic section, dynamics. Mechanics of materials, transverse, shear stress. So we need for it to be in the civil engineering section, but also in the section where we're looking at design of steel, right? So, and we're looking at spacing, right? Transverse spacing between line of holes. Okay. So we're looking for G, right? Well, how do we know G? Well, there's a few things that you're going to need to be able to remember as you're, going in and, oh, you can't even see what I'm trying to show you. Okay, so to transverse spacing, G. Okay, so in order to know this, you need to know that transverse, just remember transverse spacing is always the vertical spacing. And you can say it's the shortest vertical spacing from hole to hole. Yeah. So what I mean by that is what would be the vertical distance from hole to hole? Well, it would be so we have a hole at B and a hole at E. What is the vertical distance between the two? I'm gonna highlight it so it's there, right? So what is that? That is my 2.5 inches. Okay. What about from E to C or from E to F? Oh, be here or here. 4 inches. Okay, so transverse, just remember, transverse is always your distance from the vertical, right? It's the shortest vertical spacing from hole to hole. Okay. Why am I talking about this? Well, this is very important when you're wanting to find the net area, because what you're doing is basically you're wanting to you want to solve for your net area, so you want to be able to use G, right? You would use G to help you solve that net area, so you need to know what values to plug in for G, right? And so depending on whether they're telling you to go from C from C to E, then that your value for G is going to be 4 inches. But if you're evaluating something from B to E, then your G value is going to be 2.5, if that makes sense. So what about S, right? Because this net area is going to be very important for your staggered holes. So what about S? Well, S is the longitudinal spacing of consecutive holes. Okay, so S, just remember, S is the longitudinal spacing. Ooh. So G is in the Y direction, right? And that's the shortest vertical. Always think vertical. Spacing from hole to hole. Now, S is going to be your longitudinal. Ooh. Longitudinal. Longitudinal spacing. Right? And this is your shortest horizontal spacing from hole to hole. Okay. So what do I mean by that? Well, you're only looking at your holes, and that means you're looking at the horizontal distance, right? So this horizontal from B to E, horizontal. it would be 2.18. And then what about from E to F? That distance. This. Right. So our what is our answer here, right? So use the plate. We're trying to find the transverse, vertical distance between the holes. In this case, our answers could either be 2.5 or 4. So 2.5 and 4 inches. So answer A. So making sure you know how to read this stuff and being able to plug and chug is going to be very, very important. All right. Okay. So this concludes the design of steel components. In the next video, we're going to be looking at the design of reinforced concrete members. So I'll see you in the next video.